So in this video, I'm going to talk about how to use a Geogebra to calculate the normal distribution. In here, I will start with normal. Geogebra. Geogebra Classic. Okay. So when we choose Geogebra Classic, on the right hand side, you will see we have a graphing, geometric, and other things. We choose probability. So the default one is going to be normal distribution. If it's not, you will in here the drop down menu to find out which one is normal distribution. But the default is normal distribution. Now in here, we just need to put in the mu. In our last example, we know that the annual rainfall in Portland is 40 inches. And then the sigma is the standard deviation is 8 inches. Now they ask you, the last question, what they ask you is, what is the probability that the annual rainfall is 14.5 inches or less? So in here, you might choose x less than or greater than whatever number that you put in, or in greater than, which is, look at the shade. You will notice that it's going to calculate the outside to end of the probability. Choose the second one. It's going to be in between, which works for 13.2 inches and 48 inches, which is the one standard deviation. Or the left one is going to be less than. You can also check it by the shading. So we want to know 54% less. This is good. This is going to be 95.99%. So that means 95.99% of the rain is going to be 95.99% of the time the rain is going to be 54 inches less. All right. So now let's look at our second questions. The practice one, to find the percentage using a normal model, draw and label the model and shade the area or percentage that you want to find. In this case, mean and annual forest is that. So A, what is the percentage of time that annual rainfall is between 13.2 and 48 inches? So here we use Geogebra. In between means we want to look for the second one. So we want it to be in between 14, right? Oh, sorry. 13.2 and 48, which, oh, sorry, this is A, I type in the wrong, 48, so in here, so mu is 40, I type in that wrong, so with mean is 40, and standard deviation is A, and we want to find the probability that the rainfall is in between 14.2 inches to 48 inches. It's going to be 68.27%. Now, let's look back our practice. Second one is, what is the probability that the annual rainfall is more than 48 inches? So, more than 48 inches, that means we want to use this, the last option, which if you see the shaded area, you will also notice that more than 48 inches is going to be here, 50.85%. So you might notice that what we calculate in last video, we've got 48 inches should be 48 inches by using empirical rule, we get 17%, right? Using a symmetric. So y in here is almost 60% instead of 17%. That is the empirical rule is approximately. It just give me an estimate. They round it up, but in Geogebra, they give you the precise answer. So that's why you will see that, hey, when the rainfall is more than XX 48 inches, it's going to be 50.87%. And then we keep going for the C is what is the percentage of the time is the annual rainfall is 24 inches less. So we want it to be less. That means we want to choose this one. X is less, and you can also check it by the shaded area. If it's less than 24 inches, we got 2.28%, which is 0.0228. Again, in Geogebra, we got it 2.5, which is already very close. Last one is the annual rainfall is 54% less. This one we won't be able to calculate by ourselves because it's not the cutoff value, which is this point. This guy is the cutoff value. It's not on the standard deviation. So from Geogebra, we can get the exact probability, which is 95.99%. Okay, so that's it for how do we use Geogebra. Oh no, sorry, we still have other exercise. So we finished the activity. Now the practice. In medical study, the population of children in Wisconsin were found to have a serum cholesterol level that were normally distributed with mean 1.75 milligram per mil, and the standard deviation sigma is 0.3 milligram per milliliter. Define and draw a standard normal for the children's cholesterol in Wisconsin. Okay, so we know that the mean is 1.75%. So when we define them, we know that it's normal distributed because here tells that this is going to be normal distributed. The center is going to be the mean, 1.75, and then a standard deviation away means you adding 0.3 from the mean, which is 2.05. That's one standard deviation away. 2 standard deviation away should be you add in another 0.3, and 3 standard deviation away is 2.65. That should contain 99.7 of your data. And then subtracting 1 standard deviation away is going to 1.45. 2 standard deviation is 1.15 or 0.85. And then that should be your curve. It doesn't have to be perfect as long as you show your number 9. What does it look like? And the center, which is the peak, is going to be the mean. Then you will get full credit. All right. So next question is ask a child has cholesterol level of 2.11 milligram per millimeter. What is the percentage of the child in Wisconsin who have a cholesterol level that are higher than the child? So we let X follow the normal distribution with a population mean 1.75 and the standard deviation is 0.3. And then we want to find out the probability that X is that higher than that child, which is greater than or equals to 2.11. That's what we found out. And now let's look at Geogebra. We want to change the mean to 1.75. Sigma is 0.3. And we want X to be greater than 2.11. So which in this case is 11.51%. So or you can write it into decimal places or 11.51%. Either way. So that should be your answer. When I'm looking for the correct, I'm looking for this part. You need to write down X is follow what distribution, and the write down the probability should be greater than 2.75. You can also draw a GeoGebra graph to show that, okay, here is 1 standard deviation away or 2 standard deviation away, and this part, the highlighted part, would be your answer. The greater than should be on the right side. Next one, find the percentage of the children in Wisconsin who have cholesterol level is between 1.3 to 2.23. So again, X follow normal distribution. And then we want to find out the probability of X in between 1.3 to 2.23. Now, we can use GeoGebra. Do that. In between, we should choose the middle one. Oh, sorry, you're not able to see that. Sorry, I didn't notice earlier you would not be able to see that, but I figured that you should be able to do that by yourself in the bottom and check the answer. 2.11, 2.23. All right, so it should be 0.8784. So in here is 0.8784. Oh, you can convert it to a percentage form and then draw a graph that you know that, hey, in between the mean should be 1.7 and in between 2.23 to 1.3, which is the middle part. It's going to be 87%. Okay, that's it for today's video.